Hello, let's continue our Sudoku adventure with Consexutive by Randall. All right, so this continues our XSum theme week. I hope you're enjoying it. I will go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these values outside the grid, like this 10 here. This is an XSum clue. The X is whatever digit comes after, it comes right next to the clue. So in this case, maybe a 3. And then what we do is then that is the count. So we're counting 3 cells from the clue, including the count itself. And those need to sum to the clue. So these 3 sum to 10. So including the 3, that means these 2 need to sum to 7. So we could do, for example, 2 and 5. Now that breaks the other rule we have, which are these white dots. White dots separate digits that are consecutive. So if this was a 2, this could be 1 or 3 in order for them to be consecutive. Order doesn't matter. They're just consecutive. Not all of them are necessarily given, which means if I had a 2, 3 here in the solution, that would be perfectly fine. It would be missing a white dot, but that's okay. We haven't been given all of them. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I accidentally maybe found the break-in during the rules discussion here or here. Let's talk about this first, just because I have it on my mind. We know these 2 digits are consecutive. The other thing we know is that these 2 digits are used in the sum to 10. Because the only way that would be avoided is if this was a 1 or a 2. Well, a 1 is always 1. It only includes itself. The 2 would require an 8 here to add to 10, which I can type 8, but there is no 8 in the puzzle. So it's at least 3, which would include all of these. Now, something that I will say is there's kind of a neat little trick you can do here, is that the sum of 2 digits across a white dot is always going to be odd, because you're going to have one even number and one odd number, and even plus odd is odd. But we need to get to an even sum. And so that means we need to have the other, means we need the other cells that are involved to sum to an odd number. But I guess that doesn't really help. That logic actually doesn't really help us at the moment. So it means if this was a 3, that would fulfill it. But the problem is the 2 consecutive digits we'd have to put here would be the 3, 4 to add to 7. So I guess I could have just done that directly, but I thought that trick might help us later. So that means this has to be a 4 because 5 is a minimum 15. In fact, the minimum for 4 is 10, meaning this 1, 2, 3. Now remember, one of these has to be even, so this one isn't going to be the 2. The 2 is going to be on the white dot, and then we have a 5, 6 pair down here. Now this 10 can't be a 4. There's actually only 2 choices for a 10 sum. I don't know why I did all that even odd stuff. I just thought it was fun. So this has to be the 3. There's only 2 possible sums, 3 or 4, or number of digits. Because again, 2, 8, we don't have the 8. And then this can't be 4, so this is our 3. And then now this has to be a 2 or a 4. These add to 7. Sorry, it can't be a 4, so it has to be 2, and then that's 5. All right. Well, that kind of just wrote itself out. I think I'm overcomplicating this. This is a 1, 6 pair, so that can't be 1. Down here, we have the 1, 4, 6, and then over here, we have the 2, 3, 5. All right. This is a 14. This is definitely not going to be a 1. It's also not going to be a 6. 6 always adds to 21. It uses the whole row. So that's going to be our 4. And now these have to add to 14. We know what these add to already. That's 11. So this has to be 3. That makes that 2 and 1. These aren't 3. All right. 17 is pretty big. It's not 3 or 4, so it's going to have to be 5. Makes that 6 and 5. So the way to think about 5, it's actually really simple. All you have to do is think about what's not in the sum. There's a single digit not in the sum. Now, like I said, the entire row adds to 21. So all we have to do is do 21 minus 17, which is 4, and that means there's a 4 that's not included in our sum. And the rest will just work itself out. All right. Let's see. This 12, maybe? So this is 1, 2, 3. It's definitely not a 1. You're not using a 2 to add to 12. So this has to be 3. 3 in the corner? 2 3s in the corner, actually. This adds to 7. So to get to 12, we need to put a 5. That's 2 and 5. This is a 4 or a 6. Oh, 1 in this column. Sorry, 1, 2 pair tells us this is 6, this is 1. So I guess this is a 4. This is 3 to finish the column and 6 to finish the column. So over here, we need 2, 3, 6. Over here, we need 1, 4, 5. Yeah, this can't be 4 or 5, so it's 1. This can't be 5, so it's 4 and 5. This is 2 or 6. Were there any exums I missed? This 10. So we're using these 3. So we got to make this a 2. That's 1. That's 3 and 2. That's 6 and 3. That's 1 and 6. That's 2 and 6. Need a 1 and a 4. And we're done. All right. Really nice puzzle, Randall. I'm actually very thankful to Randall for being pretty consistently on the kind of easier side of the spectrum. We've had some difficulty creep, maybe. There's been debate about whether we've been publishing more difficult puzzles recently, but this is very much in line with Sudoku Adventure difficulty level that I would like to see. Cool. So I hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.